maximum and minimum point functions. So here we just have to, here we normally determine the maximum functions. So most especially we want to be using the second derivative text. So how are we going to make use of that? Let me tell you something here. If you hear the word critical values, or let's say critical point. Critical point is at a point when dy dx equal to 0. That is at a point at when dy dx equal to 0. So we have, or f prime of s, we have what we call critical point. And from there, we can find critical values using, it depends on how we have in the problem, using maybe quadratic method or any other one. So the first thing is, when we have equations, we firstly find our f prime of x, we equate it to be 0, we firstly find derivative, then we equate it to get the two critical values. So after what I'm saying is, let's say we have a problem, let's say we have f of x as a problem, you find it f prime, you find it's a derivative. After that, we equate it to be 0. That means, if I equate to be 0, that means I'm talking about at a point of a critical what? Critical point. So I will now have result. If it is u to quadratic, that means that we have two results. So any result I got, we call it critical values. So please do not be perplexed. I will release the materials on this. So in case if you need something under that. So the two value I got, I will have what we call critical values. The two values that we have from the problem. Then we now go back to the formula and find our f prime prime again. F prime prime means I will find its second derivative. That's how we call it second derivative text. So whatever I go for the second derivative, I will now put the two values I got for the critical values. Let's say if I find the square y over the x square, if it is greater than 0 at this point is a minimum. But if I find the square y over the x square second derivative and I got less than 0 at this point is called the maximum. So you have to take note of this. So when we solve example, we understand what we are trying to talk about. Let's see one examples. The question says find the maximum and minimum values of the function y is equal to x cubed minus 6x squared plus 9x minus 2. So you can see. So the turning point, we also call it a turning point, that's a critical point. So all those ones are turning point, that means when the y dx is equal to 0. So the first thing, I'll first find its derivative. So that is dy dx is equal to, so differential of this, I will have 3x squared. Differential of this, I will have minus 12x. Differential of this, of course, we are going to have 9. I will know this one is constant. Differential of 9, what are we going to have? Is 0. So now, at the turning point now, so meaning dy dx will be 0, critical point, so that's that. When dy dx is equal to 0, so that means this problem is 3x squared minus 12x plus 9 is equal to 0. So I would not want to find derivative for, I want to find the true value for this. So if I like, I can redo this one. If I reduce this one, so this one can remain x squared minus 4x plus 3 is equal to 0. You can see this one is it has turned to quadratic now. So let's use factorization, two numbers that if you multiply them we go 3, and if you add them we get minus 4. I think it's minus 1 and minus 3, right? So minus 1 and minus 3. So here I can have x squared minus x minus 3x plus 3 is equal to 0. So now if we factorize this, so what do we have in common here? We have x. So what do we have left here? We have done a lot of examples in elementary math. So in case if you miss that, so here, what do we have in common? Here we have 3. Factorize, that's going to be x minus 1 equal to 0. So now we can see what we have in the bracket are the same. So we have x minus 1, and the one we have outside x minus 3 is equal to 0. So this simply means x minus 1 is equal to 0 or x minus 3 equal to 0. So meaning here our x is equal to 1 or x is equal to 3. So these are the critical values. We've gotten them. So since you have second derivative text, you now go back to the y dx. You know, recall under higher order, without the y dx, you cannot have the square y over the square. You remember that? Yeah. So what we have for the y dx, what we get for the y dx is this. We have the y dx to be 3x squared minus 12x plus 9. So now, since I'm using second derivative text, I will find the derivative. That's the square y over the x squared is equal to differential of this, I will have 6x. Differential of this, I will have minus 12. Can you see that? Now, so what are the two values we have? We have two values. We have x is equal to 1. At the same time, x is equal to 3. So let's, at x is equal to 1, the first one. At x is equal to 1. So that means that we have the square y over the x squared to be. So x is 1 now. That is a 6 of 1 minus 12. So 6 times 1, we are going to have 6. 6 minus 12, we have minus 6. So this one is the first one. Then the second one at x is equal to 3. So if I go back there, we have the square y over the x squared. So x is equal to 3 now. We have 6 bracket of 3 minus 12. So 6 times 3, we have 18 minus 12. And here we are going to have 18 minus 12 here. We are going to have 6. So if you look at the first one, you can see we have minus 6, isn't it? We have minus 6, right? Is it minus 6, is it greater than 0 or less than 0? Yeah, it's less than 0. So that means here is less than 0 and here is greater than 0. As I told you, at a point where the square over the x squared less than 0 is called maximum. So that means at this point is maximum here, and at this point is a minimum. So that's all we have for differentiation. So we have talked about all the method. In case if you miss any method apart from the one we discussed so far, just kindly watch it so that you'll be able to understand all the method we mentioned. We talk about general method, how we normally differentiate. We talk about higher order. We talk about first principle, function of functions, quotient, products, exponential, trig, and others method too. So that's all we have for differentiation. So the next one we are going to is integration. So got it. Then I will finish calculus tomorrow. Yeah, tomorrow is Friday. That's all about. This is the